let's turn to the Siemens motion control topic. In this video, I collect 9 common questions when we try to learn Siemens motion control. Alright, let's review them one by one. So first common question you would ask, which kind of application or control requirements drive me to use motion control? Because for the industry control system, basically we will use the PLC as a controller. Other than using the conventional way to control the VFD or send a command to the servo motor to control the servo motor move to the positioning control, when we need to especially use the motion control or motion controller. So let's have a glance on this paper. So this picture comes from the Siemens motion control workshop. Basically, if your system needs a positioning control, for example, you need to use a screw lead to do the positioning, to transfer the materials or transfer the products, or use the pick place to pick the part. And based on the positioning control, you have to do some synchronized operation. For example, use the gear based on the speed or based on the position. Or you have to do the cam control, or do the synchronized. The slave need to synchronize with the master axis. Basically, the flying saw will do this control method. More advanced system, we probably need a delta picker or spiral robots. So in this area, we need to combine or join the couple axes together and use the model. For example, the Cartesian, delta, or spiral robots. We have a model built into the motion controller and join those couple axes together to implement this motion control. But this is a hand. Most of the cases, we will use the positioning control or the cam or gear control for the axis. And basically, we would use the servo motor to do the high performance servo control. So if your machine have those requirements, basically it will drive us to use the motion control. And in Siemens area, when we talk about the motion control, from the controller wise, we will mainly use i7-1500 or i7-1500T controller. If just to do some positioning, simple positioning control, the standard controller i7-1500 controller, that's enough. For some advanced application, for example, to implement the cam or the positioning gear or this SINAMICS, this model, we have to use 1500T controller. So among the Siemens products to implement the motion control, the i7-1500 and i7-1500T series controller, they are common used motion controller, and T will do some high advanced motion control. So when we talk about the positioning control from the drive wise, basically we will assume we will use the servo motor. However, in some cases, if the machine need a high power motor, limited on the cost or limited on the driver size, we have to use the vector. We have to use the induct motor or the VFD to implement the positioning control instead of using the servo motor and the servo motor drive. So this table would give us a rough idea when we use the vector or VFD and comparing with the servo motor, what the performance on the positioning control accuracy. We can find this table from this ID number. If you search the support.industry.siemens.com and search this ID number, and from this PDF file, you will find this table. This table gives us a rough idea. For example, when we travel distance of 1 meter, the positioning accuracy we can compare if we are using the vector control on the drive and induct motor and comparing with the servo motor drive. So what the positioning accuracy between them? Okay, this is the first question. And second, what is the technology object and what are the benefits of using the TO for the motion control? If you preview the Siemens back-off or arm motion control materials, when we talk about the motion control, they will talk about this word, TO, technology object. That's because the TO runs very important role on the motion control, and the TO is a standard method for the motion control for different brands. I would like to use those two pictures to explain this idea, this concept. If you recall, if you used the PLC to communicate with VFD to do the speed control. For different brands drive system, for example, you are using the Siemens drive, or use the backup drive, or use the Allen Bradley PowerFlex drive. For different brands drive, the communication or the data frame, they are not the same. So different brands has a different way to turn on the drive to send the speed, or the different way to stop the drive to stop the motor. Also, to diagnose the drive, different brands will provide a different way to diagnose the drive. So the benefits using the technology object, from my personal view, the technology object will run as a driver or running as an agent. And this driver joined the programming and the actual driver system together. Basically, this technology object will separate the programming and the hardware drive system, separate them to individual two parts. So as a control programmer or technician, so you could mainly focus on the programming, use the PLC open, for example, home, speed, positioning control. And from the driver side, if your company has the drive system expert or specialist, so these two technicians can focus on the different jobs in one system. And this technology object can provide a universal platform or area for the programming. So when we program the motion control, we can only focus on the technology object. So this technology object will run as an agent to provide all the information or transfer the control signal to the drive. And from the project implementation wise, we can imagine most of the cases when we order the drive system, the delivery time will be very long, basically 2 or 3 weeks. And the assembly team will start to build up the mechanical system and join the drive system and the mechanical system together. This might take 2 or 3 weeks after. From the control and the programming wise, using the technology objects, we do not need to wait the mechanical and the drive system. We can set up the TO at first and set up the TO as a virtual drive. And because the TO can provide universal information, so we can start to program using the PLC open, home, positioning, speed to program our access control. And once we receive the driver controller and once you got the power, so you can configure the TO join together with the actual drive system. So this can facilitate our commissioning and programming, and we can prepare in advance. And to find out the detailed explanation for the technology object, so you can find those two materials. It has an explanation for this TO. So you can search these IDs from the Siemens support website. Okay. And next question, which TO is a common used to control the drive and access? The most common used TOs, we will use the speed access, positioning access, synchronized access, cam, and kinematics. The most common used, especially for the positioning control, we will set up the access as a positioning access. To find out the detailed explanation, you can search those ID from the Siemens support website. One important document, you can search the motion control overview. The latest version 5.0, in TI Portal version 16. All those key information from the Siemens motion control is explained in this manual. Its ID is this 459. And the fourth question, what kind of applications need to use i7-15T instead of i7-1500? If you have a Siemens controller background, we will know the i7-1500 is a common used middle and high-end controller. And there's another series controller, a named 1500T controller. This controller especially do the job for the motion control. However, we will find many materials talking about i7-1500 controller still can do the motion control job. It is true. So we will have a question, when we have to use 1500T rather than the 1500, right? So this will talk about which kind of motion job we need to do. Firstly, when we talk about the motion control, this picture would explain something here. So this picture comes from the Siemens motion control workshop. If you are doing the positioning control only or the speed control for the axis, do the single axis movement, or do some gearing without the synchronized positioning. For example, just do the speed gearing. So the standard controller, i7 1500 controller, that's enough. If you have to do some higher end positioning control, especially for the gearing, positional gearing, cam, or the kinematics functions, for example, join the 4 axes together to use the existing model to implement the TCP control. So you have to use 1500T CPU. The T means technology CPU. And very good things is that the programming style for using the 1500 and the 1500T, they are the same. For example, if you are programming the positioning control in the 1500T and the 1500, the function block and the programming style, they are exactly the same. That is very good things. Some people will ask, so what is this? The kinematics control. That application is this. So the 1500T is built in those common used the model. Basically, the model can join the 4-axis, 4 servo motors together and implement those models. After we use those models, it's very good for the programming because after we use those models, the only things you need to take care is this TCP. It's a tool center point. You only need to take care about the TCP movement rather than the individual drive because the model already help you to organize, to manage those individual drives. And we will find that the typical functions from those 8 scenarios, their workplace, they are 2D workplace rather than the 3D workplace, whatever which model. See that? So their workplace always a flat, the 2D workplace. This is the key difference between those models and the 6-axis robot. So the 6-axis robots can do the job around the tool and can do the 3D task. But this 1500T, using the kinetics functions, those models can only do the 2D task. But most of the cases in the industry, for example, for the packaging machine or the assembly machine, those models, they are enough. For example, the roller picker and this triple and this spiral, they are common used machine and style we can see in the industry. This i7 1500T can implement those applications. In your system, if you only need to do some simple positioning control, the standard controller i7 1500 controller, that's enough. Keep in mind this. Next question. We know the i7 1500 and i7 1500T can do the positioning control, can do a multiple axis. So the next question is, how many axes for one controller it can do? So from this list, we can have an overall picture. So here, take this 1515 controller as an example. If we are using the standard CPU 1515, typically this controller can provide 7 positioning axes. And when we use 1515T, it also can provide 7 typical axes. Keep in mind this. So this picture can give us a rough idea for the standard PLC and T CPU, how large their work memory will have, and what the typical access numbers for different controller they can provide. Also, we need to take care about these resources. Basically, we do not need to calculate those resources, but when we select the CPU, actually, this motion control resources is a key criteria to judge if one controller can do this motion control task. So till here, someone will ask, even if we know, for example, this 1515T, it can provide 2400 resources, but the only things I care about that is the access number and the kinetics functions numbers. For example, in our system, if we have a 6-axis positioning control and 1 kinetics model we need to run, so which kind of controller we can use, right? Actually, we only care about this. So Siemens provide 2 additional tools to help us to select, to judge, to pre-select if one controller can do this job, especially for this TIA selection tool. It has an online version and an offline version. I pretty like this online version because Siemens always release the new controllers and the reperformance and the new firmware. So the best way to use is this, the TIA selection tool, using the online version. In our case, for example, from this selection tool, we can type in the motion control cycle time using the Perfect and how many axes, positioning axes we need to use. For example, in this case, we need to use the 6. And also we have one group for the synchronized axis. So based on this application, when we turn to select the controller, it will tell us which kind of controller we have to use. This 2 milliseconds actually is very tough for the motion control. It's a very high-end requirements and will cost a heavy job for the motion controller. So based on those requirements, when we try to select the T CPU model, the system will recommend we probably need to select the 1516T. And because we select this kinetics control, so the system will not recommend the standard CPU. It will only show up the technology CPU, and this green icon will show the proper one. For example, this 1516T. So using this TIA selection tool, we do not need to manually calculate the resources and the access number. Okay, this is a TIA selection tool. And Cider, this software is especially a professional tool, mainly focused on the Siemens drive system selection. For example, the Siemens driver system, SINAMICS S210 and the SINAMICS 120 driver system. So what the size driver system we can use. So the Cider software is a professional software to select the driver size. Also, it has a screen to show which kind of technology CPU we can select. I will use one individual video to show how we can use this TIA selection tool and the Cider software. Next question. So here now we talk about the i7 1500 controller and the 1500T. They are all PLC and controller wise. And for the motion control, we do need the driver system. So next question, what are the mainstream Siemens driver controllers I can use, right? To implement the motion control, it is recommended to use the same brand to implement the motion control. For example, if you're using the Siemens i7 1500T Siemens motion controller, you better use the Siemens drive system. And for the Siemens drive system, the common used drive controller, one is SINAMICS S210, one is SINAMICS 120 here. In some market, Siemens also provides this lower-end SINAMICS V90 server controller. V90 and S210, their power range, they are the same. But keep in mind, S210 is a higher performance than the V90. For the simple positioning control, V90 can do the very good job. But for the middle-end positioning control, the S210 is highly recommended. Keep in mind, the highest range they can provide is 7 kW. If you do need a higher power, probably we need to turn to the SINAMICS S120. The Siemens SINAMICS S120 is a very good performance server control system. Okay, for the common application, the SINAMICS S210 is a very common used server motion controller. So as we can see, the S210 can cover the middle end, even a higher end application. And we talk about the Siemens motion controller and the Siemens drive controller. So till here, you can imagine there will be a huge materials we need to search, we need to learn. For example, how we can find the documents to show how we can program the motion control. For example, how to home the axis, how to speed control or positioning control, and how we can set up the TO to set up the communication to configure the drive access, right? So that turns to a question, what is the efficient materials I can use? Here I list the 4 key materials we can use. Firstly, we can search this keyword starter guide kinematics. So this is one starter guide. It only has a couple pages. It provides multiple links. For example, from this YouTube Siemens channel, it provides schematic technology CPU knowledge, and this is automation task in 10 minutes or less. This is very helpful. And this industry automation TI portal, Mr. Automation. And from this link, you can find the efficient materials and videos. It also provides some starter kits. For example, let's have a glance. So we talk about the driver system SINAMICS V90. This is cost-effective motion controller. and this SINAMICS S210 is this style. And both 2 series controller, they can provide the perfect IRT communication with the Siemens controller here. From this 2 page, it provides the manual, FAQ, and application example. They are very important. All those documents and the materials, they are very efficient. So highly recommend you download and digest after. Highly recommend you can download. One is for the 1500, one is for 1500T motion controller. This is version 4.0, this link. But from the latest version 4.0, the Siemens joined those 2 manuals together. Follow me to go there. Then it will jump to this support.industry.siemens.com. This version 4.0 is come from the 2017 December. But from this job list, if you select this 2019 12, so it will shift to a new version. It will provide the different ID number. This is the latest manual talking about the motion control. And this manual includes the 1500 and the 1500T motion control. This motion control overview version 5.0 that can be downloaded from this ID number. And other than this, one important that motion control overview and important link, you can search this ID number. If we switch to the support.industry.siemens.com, searching this ID number, you will find this overview and the important link. From this link, we can find a huge information here. It basically includes all the essential manuals examples here. For example, the latest manual we just discussed, the motion control overview version 4.0. In the TI Portal version 16, we can download this manual using this link. Some getting started and the programming guideline, style guideline. Also, some application examples. I will use some following videos to explain some important applications. They are very handy for us to learn, to implement, to practice the motion control. This is the overview and the important links. And the bottom one, this ID number. That name is the basic of access control with the TO and approach to access optimization. So let's go to find this manual 884. This manual only has 20 or 30 pages. However, it's very important. It explains some basic concept, especially when we use the Siemens controller and the Siemens Drive controller. Siemens controller provide one key function that named Dynamic Server Control, it named DSC. The basic idea is once we enable this DSC, the position loop will be located at the drive controller. That allows the position loop response very fast and get a better position loop performance. If you are using the third-end driver system, so we cannot select this DSC function. That means without this DSC, our loop control will be in the standard PLC or in the TCPU, in the controller. So this manual explains those ideas using the loop control, this concept, especially when we need to optimize the loop control. So this manual is very important to help you to build up some basic concept for the loop control system. And very important diagram showing in this picture that procedure for access optimization if we double click this picture. So we will find for using the DSC or without using the DSC, for optimize the driver system in the TO configuring the driver system, the method they are not the same. So we can see if we are using the Siemens driver system and enable the DSC function, the commissioning will be very simple. If we are using the third-end driver system, the positioning control will be located in the CPU in the PLC side. So you have to using the TO to optimize the positioning controller. You have to manually to optimize the positioning controller by tuning those parameters. So those 4 materials, personally, I highly recommend. So next question, if you turn to learn to practice by yourself, you definitely have this question. What software I need to start up? I need to install, right? The answer is you need to install the TI Portal version 15 or version 15.1 or version 16. You can download the TI Portal version 16 professional version from this ID number. It provides the trial software you can download for practice and for hands-on. When you try to download the version 16 professional, Make sure it includes Step 7 Professional version, Step 7 Safety Advanced, and WinCC Comfort and Advanced version. And other than this, I highly recommend you can download the i7 PLC SIM version 16 or install this i7 PLC SIM Advanced version 3.0 if you have a license. They are the Siemens PLC simulation software. To practice the motion control PLC open programming, we can set the TO to a virtual access, and then we can use the virtual access to program to practice the motion control. If you are going to do a project, that project will use the SINAMICS driver system Siemens Drive controller. Highly recommend you need to install the SINAMICS StartDrive Advanced this version. This software is specially used to configure the Siemens SINAMICS drive system and drive controller parameter. Okay, those software I highly recommend to install. Last but not the least, what if I do not have the hardware CPU and the server drive? That will be the common questions, especially for the new starter or new learner. Even if for the actual project, so most of the cases, we need to order the controller and order the server drive, and those devices will be shipped, will be delivered after a couple weeks. Before those hardware arrives, how we can test our program, how can we preset the TO and practice and verify our functionalities. So basically, we will have two ways. One way is let's download and use the PLC SIM. So this picture comes from the TI Portal TO configuration. And when we try to configure this TO, this technology object, we need to configure the drive system, configure the encoder, and configure the mechanical system. For example, if we are using the lead screw like this, how many rotates this screw lead can travel 10 millimeter, for example, like this. So we need to configure those parameters in this TO. And when we turn to test our system, but at that time, we do not have the hardware. So if we are using the PLC SIM, we can check this box, simulation. If we check this simulation, the system will ignore the hardware connection, but the system will use this configuration. Basically, that means when we activate this simulation, and when we use the PLC SIM to test our motion control, the positioning feedback, the system will simulate the positioning feedback. So from our programming wise, we can test our logic. In your TI Portal project, you can still configure the hardware drive system, configure the encoder configuration, and use this active simulation to download the hardware configuration to the PLC SIM. Let the PLC SIM run to simulate the hardware drive system. So the PLC SIM and this TO, the technology object, will run as a simulated drive system and run all the parameter you set into this TO configuration. We can fire the access, we can see the motion speed and the motion position feedback. But that feedback is simulated by the system, simulated by this TO itself by using the PLC SIM and by using this activation checkbox. And another simple way is much easier, especially for the new learner. If you are not quite clear which kind of drive and encoder you're going to use, so you probably can check this. Use the virtual access. So when you check this virtual access, you do not need to configure the drive and the encoder. In the actual project, this virtual access usually will be used as the main access. Some other actual access with the drive system will follow or synchronized with this main access, with this virtual access. And this virtual access can be connected with one encoder or some other values. But from test purpose, we can still use this idea, set the access as a virtual access, and we can, based on this virtual access, test the PLC open motion control instruction logic. This basically leaves you a chance to focus on the programming, for example, home the access, speed control the access, or positioning control the access, or even test the kinematics model by using this virtual access. So you do not need to pay attention on the drive encoder, those hardware configuration. This is the activate simulation and the virtual access. And other than these two methods, The recent 2 years, the virtual commissioning become more and more famous. Siemens provides some software to build up this solution. For example, from the programming wise, Siemens has a TI portal for the PLC programming, control logic programming, and using the SINAMICS machine simulator. This machine simulator includes 2 parts. One is a PLC sim and one is software. This software provides the API interface. And this Siemens software runs the role to simulate the motion system. That Siemens can simulate the drive system behavior, the time delay, the time response, and the initial that behavior. The MCD software can simulate this mechatronic system, for example, this spiral robot, and the bell and the conveyor system, as well as the sensor. So those 3 software joined together, we can simulate one machine system. This can use to validate or verify our functionalities, our programming design, and mechanical design. Also, it can pretest some concept or pretest some functionalities. For example, test the cycle time, test if the system has some collision or boundaries in somewhere. To find out the detail, we can search this ID number from the support.industry.siemens.com. I believe in the following couple years, the virtual commissioning, those methods will be a common used method in industry. Alright, hopefully those 9 questions I summarized by myself and those answers can help you to roughly build up one basic concept for the Siemens motion control. In the following videos, I will demonstrate how can we start from one simple task, how can we manually set up the home, speed, positioning control. And then I will show how can we leverage some important application example, and how can we use some existing library to quickly build up the motion control. Alright, thank you for watching. See you in next videos. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.